Lesson 1.3a Geometric Sequences, Part 1 and 2. So now we're trying to figure out in this sequence, how do I go from number to number? From 1 to 5 and 5 to 25 and 5 to 125, you are multiplying by 5. The next one, you're multiplying by 4. And then here, we're multiplying by -4. And finally, the last one, we're actually multiplying by a fraction, because in order to get this is called a common ratio. So this number that we just figured out what we're multiplying is called common ratio. We use the letter R to represent it. So that's through multiplication. So to find the R value, you can take the second term and divide it by the number previously the previous number to it. So for example, 448, if we divide by 1792, we can simplify it as a fraction of 1/4. So that would be the common ratio. So what is R? R is the common ratio. So this is the factor that we are multiplying to get from term to term. So how can you calculate it? Well, R is equal to T2 over T1. Or T3 divided by T2, or Tn divided by Tn minus 1. So as long as it's the next term divided by the previous one. So let's say you have, for example, determine the 12th term of this geometric sequence. So in this case, the 12th term, we're going to use a formula for that. We're going to use a formula for geometric sequences that looks like this, where our general term is our first term multiplied by that common ratio to the power of n minus 1. So T1 represents our first term, n represents our spot number. So what spot are we talking about? R is our common ratio, which is this new variable that we've introduced. Tn is our general term. So let's say we're looking for the 100th term. We could use Tn to represent what is in that 100th spot. So n is 12 because we're looking for the 12th term in this sequence. We know it's geometric, so there is an R value. And how we can find the R value is taking the next number and dividing by the 1 right before it. So if you divide these values, you should get -1/2 as your R value. So our T1 is 512, so we're going to find T12, which is the 12th term, using 512 as the first term, -1/2 as your common ratio, to the power of 12 minus 1. So in our calculator, we're putting 512 in brackets, -1 divided by 2 to the power of 11. And we should find that the answer is -1/4 if we're doing this properly, or -0.25. So is this sequence convergent or divergent? So what this means is, if you look at the numbers that are positive, so if you look at the positive numbers, you're going to see that they're going to go downwards on the number line. So let's say here's 0. So we start at 512, and then we go to 128, and then so on. And you'll see that the negatives, it started back here, -256, and then it goes to -64, and it keeps going in this direction. So this is going to be something called convergent, where the numbers seem to be approaching something. We don't know what it is yet, but we know it's approaching a certain number. The sum would approach something. If we were to go in if one arrow is going down and the other arrow is coming towards it, we know that they are going to approach a certain sum. So that is what convergent means. So we're going to sketch a sequence here. So a sequence, if we were to actually sketch it, for example, if I have 1, 2, 4, and then the next number would be 16, imagine that the bottom is your term spot number, or in this case, you guys know it as n. So it would be 1, 2, 3, 4, 5. And then for the height, that would be the actual Tn value. So what is in that spot? So what is the actual value of it? So the value we know could be, we could go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So we know at term 1, we're at 1. At term 2, we're at 2. At term 3, we're at the value of 4. Term 4, we're at 16 up here. And then at term 5, we're already off the chart. We were like above here. So what you should notice is that this graph increases very quickly, and we'll put an arrow to show that. These are called exponential functions. So this is something that we actually study in 30-1 and 30-2. So exponential functions are functions that grow very quickly, such as population. Example number 2, they're saying determine the 10th term. So we're going to go T10 equals, we know our first term is 2, so that's T1, times our common ratio is going to be R is equal to -6 divided by 2, which is -3. And it's always to the power of 1 less than your n number, so 9. 10 minus 1 is 9. If we put that into our calculator, we're going to get that the term 10 is -39,366. As you can see, this sequence jumps a lot. And so they're asking, is it convergent or divergent? So on a number line, we have 2, 18. So as you can see, the positive numbers are going upwards, they're increasing. The negative numbers are decreasing, so they're actually going away. The arrows are going away from each other. So that's the idea of divergent, that their sum will not approach a value. Example number 3, we have, they want to know what our n is. So how many terms are there in the sequence? Well, we know that Tn is what is in that last spot. Well, the last spot has 384. So our answer is 384, which is our Tn. Then we put always our T1 to the power of our, or times by our common ratio. R is equal to 6 divided by 3. So term 2 divided by term 1, which is 2. And then that's to the power of n minus 1. So what we're going to do is we're always going to start by keeping these guys together. These two guys can't be touched. The reason is they are glued together. So we're going to divide both sides by 3 to start off. That gives us 128, which is equal to 2 to the power of n minus 1. Now we're going to do an example of something called a common base method. So we're going to get 128 to be 2 to the power of something. So what to the power of 2? 2 to the power of what gives you 128? Well, if you put that into your calculator, if you do trial and error, you'll find that 2 to the power of 7 is 128. So that's what we're going to replace with 128. So 128 is going to be replaced with 2 to the power of 7. And then on the right side, we have 2 to the power of n minus 1. The reason we do that is because if the bases are the same, we can actually ignore them and then only look at the powers, because if the bases are the same, the powers are the same. And then to solve for n, we're going to add 1 on both sides, and that's going to give us that n equals 8 as our final answer, which means that there are 8 terms in the sequence to take us to term 384. Example number 4, we know that term 1 is equal to 1. Then our common ratio is going to be term 2 divided by term 1, which will be 0.25. They're asking us what is the general term equation. So that's all we have in the equation, so we're just going to fill it in and simplify as much as possible. So Tn always equals our first term multiplied by our common ratio to the power of n minus 1. And all we can do is multiply, the 1 can just cross itself off because we don't need to write a 1. So that is our general term equation, because 1 doesn't affect the answer, so we don't have to include it in our general form equation. Okay, and then the copy in the puzzle is just kind of an activity if you want to try that to see if you can make the equation. So for example, to get from term 2 to term 18, you would need a 6 here in the middle. Because times by 3 and times by 3 and times by 3 again would give you then 54. And then you can do that same thing with the other examples. So we're going to continue on. So this one's just saying create a geometric sequence whose fifth term is 48. Well, an example of that would be if you had this kind of sequence. So this one is where the common ratio is 2. You're multiplying by 2 to get from term to term. And you can see that term 5 would be 48. So that would be one example that would work. Example number 1, we're going to have to look at a few kind of ideas here. You're going to first have to always change percentages to decimal values. So you're going to have to divide this number by 100 to get that it is actually 0.09 as a decimal. So that's really important when we talk about percentage increases or decreases. Now, we also need to figure out what year we're in. So in 2011, we know that we started the population counting in 2006. So we need to figure out how many years have passed. So 2011 minus 2006 means that 5 years have passed. Now if we list out the years, 2006, 07, 08, 09, 10, 11, we can see that by counting, look, there's 1, 2, 3, 4, 5 years have passed, but if you actually label them by terms, by spot numbers, if this is term 1, this is term 2, term 3, term 4, term 5, we actually have 6 terms. So whenever you find years of difference, you're going to always have to add 1 to get the number of terms. So what that means is n equals 6. There are 6 terms in this sequence. So that's going to help me because we're finding term 6. Now the equation that we're using is going to be our first term, which we know the population was 29,927. Our common ratio, whenever we have a growth, we're always going to have to do 1 plus the decimal value that we found. So the population is actually increasing by 1.09. If we just use 0.09, the population would actually decrease, which wouldn't make sense because we're talking about an annual growth rate of population. So our R value is 1.09 to the power of n minus 1, which is 6 minus 1. So then we would put this into our calculator and get that the population to the nearest 1,000. So I'll show you what the number is without rounding. And then this would round to approximately 46,000. Because you'd be rounding these numbers down because this is the 1,000 spot. Okay. So that's something to keep in mind. These numbers are rounding that 6 to stay as it is. So that would be the population, the approximate population in the year 2011. So they want us to find now 2030. Well, we're going to use the same ideas, except we need to figure out what term we're talking about. So step 1, take 2030, subtract 2006. That's going to give us 24 years, but we have to add 1 to give us 25 terms. So we know that there's 25 terms in this sequence. So we're finding term 25, which is equal to our first term multiplied by that common ratio to the power of 25 minus 1. If you put that into your calculator, you're going to get, again, to the nearest 1,000. So I'm going to give you the exact, what we found, and then I'll give you the rounded version. So that's approximately equal to 237,000 people. So assumptions that we're making is that this rate is always going to stay about the same. So this growth rate of 9% is going to be the same, and that that there's not going to be too much affecting the population. So those are things that we're assuming. Example number 2, we have our first term is equal to root 2. Our common ratio is going to be taking root 6, dividing it by root 2, and that's going to give us square root of 3. So when we're trying to find term 9, in this case, we're going to take our first term, multiply it by our common ratio to the power of 9 minus 1. So this is going to be square root of 2 multiplied by root 3 to the power of 8. So if you put square root of 2 or square root of 3 to the power of 8 in your calculator, you're going to get that that is 81. So we can write it then as a coefficient of 81 times square root of 2 if we want to keep the answer exact. So this would be the exact answer for term number 9. Example number 3, they're giving us that our first term is equal to 27.5. And then our fourth term is equal to 32.7. So what we don't know is what the common ratio is, but we do know that we're trying to find out what is so I think that's it. They just want the common ratio. Okay, so what I'm going to do is I'm going to fill this into the equation. So this is the equation that we've been using as of so far. Tn, we're going to use term 4, which is 32.7 as term 4. T1 is 27.5. Our common ratio we don't know, but the n that corresponds to 32.7 is 4. So step 1, to solve for r, we're going to have to divide the t1 to the other side of the equation. So I'm going to have to go 32.7 divided by 27.5. And I will get as a fraction 327 over 275. And our last step is to cube root both sides. So if you cube root this answer, so you can go 3 math number 5, or you can go math number 4. So if I press math number 4, that will give me the cube root button, and then you can take that answer and plot it in there, and you'll get approximately, if you round to the nearest hundredth, your R value should be 1.06. Now example number 4 follows a video, so we're going to skip that one because there's a video that's involved for that one. The next one we'll do is example number 5. So this one, we have the second term is equal to 28, and the fifth term is equal to 1792. Determine the value of T1 and R. So this is an interesting method. So I want to show you what I would do for this one. So what I would do is arrange the equation for this, where 28 equals T1 R to the power of Okay, so for this example here, let me just clear this off. Remember Tn, this is your Tn value, and this is your Tn value. So we're starting with the first row only, and that's why we put 28 in the Tn value. T1 we don't know, and R we don't know, but we do know that n is 2 when it gives us a value of 28. So we're going to simplify this to 28 equals to T1 R. 2 minus 1 is 1, which we don't have to write a power of 1. Now we're going to simplify this one here. So 1792 equals our first term times r to the power of 5 minus 1. So 1792 equals term 1 times r to the power of 4. So what we're going to do is we're actually going to line these equations up by division. We're going to divide these two equations with the bigger one being divided by the smaller one. So the reason I'm doing that is because if you do this properly, you'll notice that the term 1s will cross each other off because of division. And then we'll also notice that r4 divided by r1, if you don't see it, there's a 1, will actually become r3 because you can subtract the power. So 4 minus 1 is 3. And then 1792 divided by 28 equals 64. So our last step would be to cube root both sides, and that gives us an r value of 4. So once we find the r value of 4, we can now find the first term. So we can go back to the equation where 28 equals t1 times r, and we can replace r with 4. So this is substitution that I'm using. So we're going to divide both sides by 4 and find that t1 equals 7. So if our first term is 7, to get from term to term, you're always just multiplying by that common ratio. So if I multiply this by 4, my second term is 28. And if I multiply this by 4, I get 112. And now I've answered all three questions. I've answered t1, r, and the first three terms of the sequence. Our exit task, if you guys look, the r value is going to be 4 because when you take 12 and divide by 3, you get 4. T1 is 3. And they're saying, what is the value of r? So what we can do is just figure out what the pattern is. I know that 48, if I multiply it by 4, I'll get that, that should be 48 times 4 is equal to 192. So I know that 5y plus 7 is supposed to equal 192, just by following the pattern. So I'm going to then subtract 7 on both sides. And I get that 5y equals 185. And lastly, I'll divide by 5 to solve for y. And you should get that y is equal to 37. Okay, so that is your lesson 1.3 and 1.3a.